What? Magnitude sign. Oh, I have a set value. Slider set value. Hello, Joao Victor something, Vitino. Which lips do you use? Can you be more specific? I use a lot of lips. A lot. I'm using a Cairo window, which is written by myself, and it's written on top of lib Cairo. So you have to Google for Cairo graphics to find that. So the Cairo graphics is pretty low level. Hence the Cairo window thing. Which is on GitHub. Just my GitHub. Should be able to find it. Oh wait, it's a different scale. Okay, let's put this one down. Put this one. Oh, yeah, that works. Okay. Now it's in 6. Wait a minute, I have to put this one very low. Okay. Yeah. We move this now larger than 0.05. The other one should move along, and it does. Okay, is there something else I can test? This one should not be able to get below the absolute value of this one. So let's say set this one to -5, then it should not be able to move this one below 5. What happens? Just gets stuck and then it jumps to -5. Works for me. Good, 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 good. Hi, AG. Calculate the cubic coefficients. The constant is the product between all the roots with the minus sign. I just keep having no idea. I just keep having to steal from myself. Well, a Bezier fitter is involved. I know that. Plot curve looks good. Yeah, just make it a lot more. No, wait a minute. This thing takes a point, doesn't it? It takes a bloody point. Yeah. I can do an x comma the cubic of x. Cubic polynomial is not known. Yeah, it is a point, not a double. I forgot. I knew I missed something. Right, so this is our initial cubic. with 0 at a half, and at 1.5 and at 2.5, which are these values. So we change this one, then it's gonna do that, yep. So I can't make this one, so now we are shifting this root here, and I can't make this one smaller than that one, in absolute value even, but in this case it just moves to the left until we bump into it, which means that it becomes minimum at that point. Now both roots are at 1.5. You can shift this out independently. Also make it very close to 0. So yeah, what I want is to be able to detect when the smallest root is very close to 0. So what kind of cubics are that? That's these kind of cubics, apparently. So here it is, it's the shape of the thing doesn't change, right? I mean, I'm constructing it from 3 roots, so it always has 3 roots, which means that it always passes the the y equals 0 line, the x-axis, 3 times, and it's a monic cubic. So the coefficient of the x to the power 3 is 1, which means that if x goes to infinity, the function goes to infinity. So it always comes from the bottom, crosses it, goes down, crosses it, goes up, and goes to infinity. So that's what I mean with the shape is always the same. However, this is possible. You smoothly go from the small root being this one to the small root being the one in the middle. And in between, it's just a shared one again. Now, both are small. There's a jump here now. Okay, so I'm trying to find the roots, yeah, so the places, values of x, where it crosses this x-axis here, with, yeah, I mean, the best value that fits in a double, which means because the exponent of a double is huge, I mean, it can adjust to anything. To well, 308 or something, but that's so big for me that I really don't. I'm not concerned that that is going to be a problem. So that means that if I want to make full use of whatever fits in a double, the resolution of a double, then we're talking about a certain relative error. So the relative error of the double must be very small, like 15, 16 bits precision. And that means that the zero, the root that is the closest to zero, so in this case it's 0.008, it's not really zero, but it looks like it is zero on the graph. That must be in absolute terms more precise than the other roots, because we want to have a we want to have an equal relative error. So this root is like a few hundred times closer to zero than these roots. So the absolute error must be a few hundred times less, more precise. Yeah, it must be a few hundred times more precise. So especially calculation of this value is sensitive to floating point round-off errors. For example, the way I currently find it is by finding, for example, this root first, and then from there jump over here, which is then by coincidence between fat quotes close to zero, and we are easily ending up very inaccurate, because it's a difference between this and something like it. So never we're going to get the precision that we need. Instead, I should really go for calculating the root that is close to zero immediately. It's not true, by the way. It's another problem, actually. I'm not calculating this root. I'm shifting the whole thing. Okay, this is not normal anymore. What is that? Let me just turn it off, the music. Well, music. Before someone wants to claim copyright on that kind of noise. Yeah, so I want to calculate this one first. Well, no, what I was saying. What I'm doing is I shift the whole cubic so that the inflection point here becomes at x is 0. And then we calculate this root first. So this shift happens, which means that on a little right. So this is going to be the root that we calculate first, and then I shift it back. But that's the same thing, of course. To just go from some value in the range of 1 to something in the range of 1000. So you lose a factor of 1000 in precision there, a relative error anyway. Relative precision, maybe it's a good word. That's why this is the wrong approach for finding this root. So now I was wondering if I cannot simply detect in advance which root, if any, is close to 0, and then calculate that one first. Pretty sure we can just divide all the coefficients by the coefficient of x to the power 3. That should not change anything. That doesn't even change the value of the roots. It's literally a scaling of the y value. So now we have a monic polynomial like this one. And the shape will always be like this. Well, assuming it has, it crosses the x-axis 3 times anyway. So I think I should classify the cubic. Like this is a certain class. I mean, these are more or less, well, maybe it's because it touches it here, it's maybe a class of its own. But in terms of calculating this point, I think it doesn't really matter if this is touching or that it actually goes through it. I would throw this one in the same class. The point being that the root, absolute value of the root here is much smaller than all other distances involved. That is from here to there, from here to there, from here to there even, from here to the maximum, the minimum, the roots. Which certainly is also the case in this case, you know, because now the minimum and the two roots here all have the same value. And this one is, yeah, I mean, it's smaller, but also still. Much larger than the 1000, right? It's more than 1 even. So when does that classification change? I think it changes when we get in this neighborhood specifically. Because now the distance from this root to this other root and the maximum is getting very small. So that might require another approach. I'm only concerned to begin with cubics where might as well take the other one. I can't make this one now less than 0, but I am on. I'm fine, I'm good. It should here be, I should go eat actually. Yeah, let's allow R0 to go negative, why not? So now this is easier to get close to 0 though. Yeah, let's try -1 to that. I'll just set the initial value to 10,000. I think this correction here still works, right? Absolute value of, already had absolute value around R0, which now can be also negative. And here as well. Okay, so now I can move it also a little bit to that side or that side. So we should also be able to recognize when it is not small. For example, this one. Now none of the roots are super small, are much smaller than the other roots. I guess it wouldn't even matter if the maximum is exactly in 0. So now maybe the maximum is 0, but who cares? I'm needing a different algorithm than what I have now. Only ones are 0, which is the smallest root, is close to 0, like here. Let's put it at so small as I can get it. So 0, yeah, well, it's a bit too small. Can't get it smaller than 5,000. And then, like I said, I think this is classification 1, and then we get here classification the next one. And then, if I move it further, the 0 root is now in the middle, so that's definitely another classification. So maybe this is left or right, might be also different, but super close. I would say, okay, special case. So maybe 1 case, 2 cases, 3 cases, 4 cases. And oh, and that one, yeah. Now it's even the third root that is close to 0, because, well, the others are just negative now. There is no real difference with, not really difference with the other, with when it is mirrored, but then, yeah, I would have to make the coefficient of the x to the power 3 minus 1 instead of plus 1. But since that's the only difference, then it's hardly a difference. It's just like class A and class A minus or something. So for now, I would say set the largest root. Let's concentrate on having the largest root just be large. So this must be an absolute value, or 0 must be the smallest root, which I now have negative, but okay. It's still in absolute value very small. And then this one must definitely be larger. This one sits in the middle in absolute value. So that could be equal to that one, and then we still have a problem, because then both are much smaller than this one. This one can just be large, so 4, 10. And I'm going to concentrate on it just being 10, not minus 10, to make it positive. Or then I don't see anything anymore, so maybe make it 5. And then you can investigate all classes by sliding this one. Oh no, I push it to 10. So this is just going, we go up till 10, and how high do we go? Just make vertical till 100 for the moment. You can see what happens. No, yeah, not what we want. True means that the ratio must be kept the same. So I'm going to set this at 10, this one at a very small number, and then see what happens if we change this. Okay, so we call this classification 1, and then we get classification 2, maybe 3 already here, and then we have classification number 4. And of course I should be able to detect when it is none of these classifications, because this one is just way off. If we set this one, it's not much smaller than that one, then you still have this point where it is super close to the other root, but it's not close to 0. Jumps from +1 to -1 here. Yeah, I think we can detect it by the fact that the value of the cubic itself at x equals 0 is significant. See, so now it's here, which is, I don't know, +10. And if I try to get closer to this, it just doesn't want to, because the absolute value of this middle slider must be larger than the one here, which is already 1. So I can only jump from 1 to -1 while still keeping my restrictions. So at most you can jump to -1 like here. And then this one jumped from +10 to -10 or -8, whatever it is. So we're definitely not close to 0 here. So we can evaluate the cubic at 0, and if then we are just far away from 0, then we have no problem at all. And if one of the roots is close to 0, then that value is going to be close to 0. But what is close? I mean, this is way closer to 0 than that. And if I scale the whole stuff, then this is just close to 0. It's just no matter how you look at it. So it is kind of, I guess the only thing I can compare it with is the value of the minimum here. Yeah, maybe that is the case. So this is a minus, I don't know, -8. And this is -100. So that is a little bit more than a factor of 10. And not a factor of 1000. And what I could do now is just move this 0 all the way to the right, further and further and further and further, which makes this thing go down, 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 until at some point that minimum is factor of 1000 lower than this point. So that has to become 10,000 then. Probably means that this root is also way larger. And in that case it starts simply to look again like this. So now I have to make it, let's say, minus 1/10 instead of minus 1. And then put that one there. Wait a minute. Where's my jump? That's almost not visible. It's just not 0. No, it's not 0. It's 10th. So at the moment we jump, say, from plus 0.1 to minus 0.1. We have the same situation again. But now this height is a very small compared to that distance. That's simply the... Yeah, now it's looking again like it was looking before, with 1/10,000 here. So 1/10 is also already pretty much like this. Which means that now if I move this slider up and down, I should get all my classifications again. Yeah, okay. Doesn't look like 0 here. It's reasonably close. Okay, but now this distance is pretty much again not 0 compared to that distance. So we treat this as a normal cubic, and then if you go down, this becomes larger and larger while this becomes smaller, and at some point I'm gonna say, yeah, okay, now it's special. Now it's really close, this distance here. Really small compared to that one. So then I go specifically looking for the root close to 0, which would be that one then. But how do I know that it is this one instead of that one? Well, that is because the roots are symmetrical, left and right, by now. Once we get this close, around the maximum. So since the maximum has a positive x coordinate, the one on the left must be the closest to 0. This is only further away, and this is going to be closer. Until until the roots become the same, the different sign but the same absolute value. Now the maximum is at 0, and then both are equally close, as you can see, and then but still the different sign. How do I see that it is a different sign? Well, because now the maximum is at 0. And if we move it down further, then it jumps again to minus 0.1. So now the maximum has a negative x-coordinate, which means that the root on the right is the closest to 0. That's the switching point. So now I have to go after this root here. And then if you shift it down further, then it's always that root. The root on that side. That is the closest to 0. Until again this vertical distance is no longer much smaller than that distance here. I think I got it right. Okay. Should probably write this down. Yeah, I have to put it down, otherwise I forget it. So for a monocubic, calculate x maximum. We calculate x minimum. And we calculate value at x maximum. And we calculate value at x minimum. And we calculate the value at 0. And I'm going to say if the absolute value of P0 is much smaller I've been working with R2 being positive though, so it could be slightly different for the other case, but okay. Put that down, okay. So assuming R2 is larger than 0. So now then, if the absolute value of the cubic at 0 is much smaller than the absolute value of, well, it's going to be negative in that case. But okay, the value at x, the minimum, which happens to be minus the value of the cubic at x minimum. Yep. Then if the value at x maximum, so that is this value, is well, I don't know, larger, significantly larger than yeah, I'm going to say, yeah, I don't know, larger than what? Large enough, say. Positive. And yeah, I'll just write down significantly. Or 2x, hey, whatever. Larger than than what? I think P0. Absolute value of P0. Now we call that class A. Yeah, otherwise we have this. It's still larger, but not significantly. So otherwise, larger than absolute value of P0. But not significantly. Then I will call that class B. And then let's say note. Wait, that's not really true. We could make this positive. True. Yeah. No notes. Okay, I'll make it even smaller. That would be the jump point, I think. This. Why is it saying? Oh, never mind. Still. Yeah, like that. I guess now it's negative. Yeah, it's hardly visible, but it is negative. the P maximum is always positive, so it's just nonsensical. This is the difference. Yeah, I think I got it. Huh? Did I start the thing again? I'll turn this. I think I want to do some real music. This is bullshit. Fuck. Okay, well, I wrote it on paper, but maybe I should write it down somewhere else as well. And it's going to end up in this file, I guess. Let's begin with adding it here. Just wrote it down here. So we classify cubics into 4 classes. It's probably nonsense what I'm doing now, but I just wanted to have black on white, or actually white on black. Where's my formula for the cubic? No formula. The first derivative is c1 plus 2c2 times x plus 3 times x squared. Go. Wait a minute. It's minus b. I'm getting a c2 here. Plus or minus, would we take the minus because a is positive? We want to the left one. Divided by 2e, 2a, so that's this one. And here we have b squared, c2 squared, minus 4ac. So that is 4 times 3 is 12 times c is c1. And again, remove the 4 here. Get the 2 here, and then divide by 2. I don't think it makes any difference if you write them as double literals or as integers, but okay, so need a header file of that one probably. Tools. So this is clause D. I wouldn't have a clue. That's not clause D. This is clause A. It quoted a room. We have a clause C. No clause B. Interesting. What the hell? Yeah, now it is clause A. Okay, so this works. And then when we go here, it should switch to B. Does not switch to B. We fucking get. Oh, there's B. Okay, so now it becomes B. Stays B. And now it switches to C, I think. Yep. And then at some point it becomes D, I think about here. Okay. Yeah, this is as expected. But. So we make this thing really small. Switch almost instantly now from A to D. There's a B there now. It's just precision of the slide is not good enough. Okay, but if I make this positive, then suddenly something weird's changed. No, this is clause D. That's not good. Okay. Oh shit. Class A. Okay, that works. Let's put this one at 10. This is class A until... Okay, let's make this a bit bigger. Definitely still class A. Now it becomes B. Oh, oops. This is B and then A. And if this is negative, it's still A. And B here. It's not English what you just said, but I see something with Discord. I think you asked this before and I gave you a link, but then maybe you already left or you didn't see it. So I give you a link again. Didn't you join before? You're already there. Now I see you already joined, so not sure what you mean. Make okay, now I'm confused. Interesting. Class D. Why is this class D? No, it's not class D. Yeah, it's the other way around. Yep, now I got it. Except that if this is very large, I mean, I don't know, close to that one. This is not really class B. I don't want to see this class B. Why? What was that? That was because yeah, because this distance now is not super much smaller than this distance. So that has to be a demand as well. think I'm going to make food. Yawn. What an annoying way to play against my Sicilian. No, lost a pawn. I could give check. Whether, yeah, next he's gonna take here. Is that good? Yeah, yeah. I don't know. I did run out of time. Yeah. Finished. Okay. Tja, 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 tja. Yeah, see, this is not a good move. You give check and I lose my pawn. Oh, I do not lose my pawn. I could play the bishop. Oh, damn it. But I didn't. No, not even that much worse, though. Question mark. Blocking his own bishop. And still I lost. Nope, not good. Yeah, unpinning my own knight is not a good, it's not a bad idea. Threaten to take here with attack on the queen here. Double attacked, he can hardly even defend it. I just take it anyway. So what happens if I do this? Push the pawn. Okay, and then I take it. Yeah. Easy peasy. And if you would do an attempt to defend it, you can just start developing on the queen side. Still developing. Threatening to do this, attack it again. He must castle. I can just kick the knight and then take it. Okay. This is bad. Yeah. He just defends it. This is not enough. Defends it again. Yeah, good move. I've not seen that. I thought about it. So he takes here, it's not check, and then I can do something, but I didn't see what. But I probably just can take the queen, and then if he takes, I pin the knight, and even if he tries to defend it, I can push this one and win it back. So we throw open the center while the king is still in the center. That's a good idea. Plus I got rid of the defender of this pawn. Looks like a good move. But instead I push the rook, question mark. Now there is no taking anymore. That's also bad. It's already bad. Oh, I could have given a fork here. You gotta be kidding me, I didn't see that. I could go there, pinning it. Do this, it goes there. Oh, but then I have this. Yeah, brilliant. Yep. That would have been a very good move. Now it's equal again. Did not see the fork. Nope. My God. Oh my God, yeah, I should have taken the bishop here. Wait a minute, I take the queen, take bishop. If I would have taken the bishop, then what? Take. Yeah, it's just been a rook. Not. From here. What? And this is not good because took here, take with the queen. Oh, yeah, and there's bloody knights on this. Cha. So much lost chances. That's also a question, double question mark. Should have taken here and then it was still equal. I had no time left. I was just taking stuff without calculating anything. Okay, from this position, if you can win 2 points here, if he takes back, then I take that one as well. So that's a full rook. And if he first takes my rook with check, then I take back, and then I still have one apiece. Yeah. So by doing this, I give away a piece, basically. It's just stupid. More than a piece. It's -7. Completely lost position. -9. Okay, yeah. That was the big blunder here. The big blunder that I took this knight here. This guy played so fast. Okay, so food. Yeah, let's stop the stream.